the mole. This tutorial will explain what the word the mole means in chemistry. Let's start by comparing a carbon atom to a sulfur atom. Now, a carbon atom has got 6 neutrons and 6 protons. So that means that a carbon atom has got a relative atomic mass of 12. Sulfur, on the other hand, has got 16 protons and 16 neutrons. So that means it will have an atomic mass of 32. Now, clearly these two atoms have got different masses because of the numbers of subatomic particles each one has. So if we were to measure out in grams 1 gram of carbon and 1 gram of sulfur, they wouldn't actually be the same. They wouldn't be the same because 1 gram of carbon would contain more atoms than 1 gram of sulfur. So even though the masses are the same, in terms of particles, 1 gram of carbon isn't the same as 1 gram of sulfur. In chemistry, we can't use masses measured in grams to compare the numbers of particles of atoms. In chemistry, we have our own unit to measure the number of particles, and this unit is called the mole. Now, the mole is a word used to describe a number. So 2 more examples of that is the word dozen, which describes the number 12, or the word score that describes the number 20. The word mole describes quite a large number. It describes this number, 6.02 times 10 to the 23. And that is a very large number, as you can see. The reason why we use such a large number is because the atoms that we are counting are so small. So if you have 1 mole of anything, it is equal to this number. So if you have 1 mole of carbon, that is equal to 6.02 times 10 to the 23 particles of carbon. Same goes for 1 mole of sulfur. It's that number of particles of sulfur. You can scale these numbers up and down, so half a mole of sulfur will be half 6.02 times 10 to the 23. You can pause the video now and have a go at these 2 questions. There are the answers. So the unit, the mole, is what we measure the number of particles in. In exam questions, this phrase is normally used instead. The mole is used to measure the amount of substance. So whenever you see amount of substance, what that means is the number of particles measured in moles. That number has got a name. It's called the Avogadro constant. We can use this number to measure out numbers of particles. In a lab, we only have balancers or weighing scales, and they can only measure masses in grams. But there is a link between the mass and the number of particles. And the link is this. 1 mole of atoms is equal to the relative atomic mass of that atom. So, if we wanted to measure out that number of hydrogen atoms, from the periodic table, the relative atomic mass of hydrogen is 1. So we would measure out 1 gram of hydrogen atoms. Likewise, if we wanted to measure out that number of particles of carbon atoms, which is equal to 1 mole, we will measure out the relative atomic mass of carbon, which is 12. So now you can use the periodic table to try and fill in these gaps for these atoms. And there are the answers. The same rule applies to molecules too. 1 mole of molecules is equal to the relative molecular mass. So for example, if you have 1 mole of hydrogen molecules which contain 2 hydrogen atoms bonded together, the relative molecular mass would be 2 grams. That is equal to 1 mole of particles. If you wanted to get 1 mole's worth of water, then you would weigh out 18 grams of H2O molecules. The relative molecular mass of water is 18 because you have 2 hydrogen atoms and 1 oxygen atom. So the relative molecular mass is 2 times 1 plus 16. You have a go at filling in the gaps. Now pause the video and have a go. There are the answers. And notice the last question there, sodium chloride. That isn't actually a molecule, it's an ionic compound. So we shouldn't really use the phrase relative molecular mass for something that's made out of ions. So we have another more general term we can use, which is the molar mass. And that's the mass per mole of any type of particle. So we can use the term molar mass to describe the mass of an individual atom or molecule, ion, or an ionic compound.